Hello, my wonderful dear friends. It is so great to have you back. Oh, we are back for part two of the Where Are We series. This time it's from beautiful Riga, Latvia. Another excellent backdrop. I love doing these random backdrop intros. It inspires me to go find cool views all over this Europe trip I'm on. But anyway, I was going to make this a three-part series. In the last episode, I said it was a trilogy. Well, we got too much awesome stuff to share with you guys, so it's going to actually be four parts. That's the first update. This is part two with the legend Flat Earth Dave, and that name kind of gives it away. You know what's coming, baby. It's time. So the next two episodes are going to be the first and second half of this interview. And like I said last time, very visual heavy, so make sure you're watching this one on video. I even thought about just making these YouTube videos and Rumble videos only and not even putting it on a podcast, but since so many podcast players are including video now, I figured I'd just throw it up there. So yeah, and I mentioned last time as well, Fountain now has video capabilities, so really cool that all the folks over there can watch this now. I looked up the stats and the majority of my listeners are on Fountain, so good for you guys being part of the future Bitcoin integration. Love to see it. Yeah, taking full creative control on this one. Really just went all over the place again, but I think you guys are really going to like it. It's full of signal, and I hope you enjoy.
Anyone that's listening, don't tune out, right? Because when you see it, you can't unsee it. And then you realize that this is the foundation for all of the other lies, all of the other nonsense. Oh, Dave, why are you talking about flat earth? There's wars, there's child trafficking, there's famine. All of that is because you don't know where you are or who you are or what this place is. All right.
Okay, we are live. Hello, everybody. Thank you so much for joining me again today for another episode of the podcast. It is my favorite time here on the podcast where we have a completely out of left field new topic that we bring into this space. And it's been really fun for me to experiment throwing this one out on social media just to see what people say, because yet again, we have this crazy conspiracy theory that everybody knows is completely insane. But yet, when you start actually digging through it and looking at what the people are saying within it, they have some interesting points. And I have someone here today who has brought a lot of interesting points to my attention with his YouTube channel. His name is Flat Earth Dave. Thank you, Flat Earth Dave, for joining me today.
What's up, Ben? We all have the same story when we first heard about Flat Earth, whether you're just a normal person or a conspiracy analyst, I like to call myself. Flat Earth is just a step too far. It's the dumbest thing ever, right? I was doing a podcast called Deep Inside the Rabbit Hole, looking into all the other major deceptions. I won't say any of them because YouTube doesn't like them. And people started sending me Flat Earth stuff, and I just deleted that. I was like, oh, that's stupid. That's funny. And then they'd be annoying. I'm like, okay, you're banned for life. And I wouldn't even let them comment. I'm like, you're too stupid to listen to our podcast if you think the earth is flat. But then I was forced by another researcher, Sophia Smallstorm, who did some incredible documentaries. And I didn't go into it with an open mind. I went into it with a closed mind. I said, I'm just going to prove this, just prove Flat Earth, prove the globe, and get rid of all of you idiots. And for 2 weeks, I didn't sleep. I was
you are
like,
making the truth-seeking movement look bad. You're subverting the truth movement.
Yeah. That's what I said. It's like it's good. I go, Flat Earth is, and I immediately came to the conclusion, the foregone conclusion, Flat Earth is a psyop to discredit the truth of community. And I was like, that has to be it. And I literally jumped to that conclusion. The globe is the psyop. The globe is what keeps us in prison. Right. And they don't care about anything. Here's where I'm going to, anyone that's listening, don't tune out. Right. Because when you see it, you can't unsee it. And then you realize that this is the foundation for all of the other lies, all of the other nonsense. Oh, Dave, why are you talking about Flat Earth? There's wars, there's child trafficking, there's famine. All of that is because you don't know where you are or who you are or what this place is. So hang in there. And once you go flat, you never globe back. So there you go.
Amazing. Yeah. And I will say, just as a brief story of mine, like I said, I was definitely in that camp as well of this is just too far. I mean, obviously that is the one we keep saying, okay, this is the one that's actually crazy and we're not going to go that far. For me, originally it was chemtrails, like, oh, obviously that one, everyone knows that's a joke, that's not actually real. And then I go down a rabbit hole on that, and right now as we're recording this, everyone is seeing this literal rainmaker company cloud seeding around Texas right before it floods the whole place. So it's becoming more and more mainstream, and more and more open to people talking about these things are really actually happening.
I've been talking about chemtrails since the early 90s.
Wow.
And people thought that I was crazy. And now that they admit it, that there's patents, that they outright admit it, those people still think I'm crazy. Because you can lead a man to knowledge, but you can't make him think. All right. And it's wild. But since you mentioned it, Sean Hibbler, probably don't know that name. He did some great documentaries on Flat Earth and some on other things. He is literally moments away from releasing a documentary called Climate Trails. It is a game changer. It's going to take the awareness of this topic to the next level. And it's amazing. So that's coming out. Keep an eye out for that. Climate Trails by Hibbler, Hibbeler, Hibbler Productions.
I love it. Yeah, I think the documentaries are truly the key to helping people out here, because there will always be the people that say, like, oh, you're just sharing documentaries everywhere. That's not proof. That's not evidence. It's just a movie. But a good documentary will bring all the proofs and evidence together in a powerful way that really gets into people's brains. So I will always promote those out there. I'll definitely watch that. Sounds great.
I live in Connecticut. Okay. 10 minutes later, if I said, where do I live? What would you say?
Connecticut.
Yeah. So you consciously looked into your subconscious memory and said, oh, he said he lives in Connecticut. That's where he lives. Do you believe it or do you know it?
I guess I believe it because you said it.
Right. So you stored it as like, why would he lie about me? He kind of has a New York accent a little bit. Maybe that's right near New York. You know, you had all these things in a fraction of a second. You stored that as, yeah, it's true. Gun to your head. Do I live in Connecticut? You know, you're not going to freaking make that. You're not going to answer it. So belief is the enemy of knowing. And when you talk about documentaries took time and money and effort to put the information together for you so you can watch it. Then you can go verify it. Okay. So at the end of the show, you said to me before the show, you want something that you can send to people that are newbies to help them get in. I have that playlist for you, and I'm going to tell you where you can get it. And I have a challenge. I say you can't get through the first 3 videos in, I think there's probably 20, 30, or 40 videos in the list. You can't get through 3 of them without becoming a flat earther. And so hang in there. This is a life changer. What difference does it make? I still have to go to work on Monday. I don't even know what today is because I don't have to go to work on Monday. It changed my life, right? And that's what we were programmed to say. We're all I know exactly the arguments that are in all of your heads because they were in my head, that we were all programmed to make these arguments. So back to you.
Yeah, couldn't agree more. And I love just loading the show notes with these links where people can go learn more. Because like you said, I want this to just be an intro where people can start their own research. I never want to say this is what you should believe. This is the direction you should go, but just giving people an opening to begin their own journey, because that's how the best learning is always done. So,
and I assume most of your listeners are aware of government deception, and
Oh yeah.
Okay. All right. So that's good. So
we can start from that foundation for sure. We're not trustworthy of authority here.
The biggest problem that people will tell people about flat earth. They'll do a really good job telling them. They're like, wow, I'm really interested. Person's going to go home and start Googling. And then they get all nonsense. And the next day they're going to be like, oh, you're crazy, man. I watched some videos, guy, Professor Dave, I watched it. They're going to feed them nonsense. And all we say is watch our nonsense first. And you'll find out that it's not nonsense. It's actual common sense. And the pseudoscience that you've been taught as fact is the nonsense.
Yeah, and we talked about earlier this idea of subversion is sort of, we're all paranoid about it for some good reason. We're thinking, is this just a giant subversion attempt to make truth people look stupid? But what the real subversion that you see, like you said, is going on Google or YouTube and typing in some of these things, and you see these force-fed, approved people just making what the actual statement is look crazy. And one of the things I found interesting which is smart, as part of your process of even signing up to do an interview with you, is do not have this flying pancake through space picture on the thumbnail because that is like exactly what you see when you Google this. When you just Google flat earth, it's like this. Yeah, there we go.
You get that.
That's the first thing that people see and the first thing you think of in your head. So tell us a little bit about this image here, because I think that's where most people, when they hear flat earth, that's what they get. So
that's what I thought. We were programmed to think. When you think of flat earth, you think of a pancake in space. That's 2 false models. That's we're not in space and we're not a pancake. Well, all the other planets are round, right? Are they? We'll get into that as we go through the stuff. The only thing you can say about anything you see in the sky, other than like an airplane or something, anything that's in the sky, is that it's a light. You don't know how far it is. You don't know how big it is. You don't know what it is. You don't know anything about it. The sun, the moon, the stars, asteroids, they're just lights. I'm not saying they're just lights, but that's the only positive claim that you can make, is that they're lights. You don't know how big. You don't know how far. And we can prove that they're not the distances that they tell us. I can't tell you what the distance is, but I can prove they're not the distances that they tell us. They're not even a fraction of a fraction of a fraction of those distances. And so when, last night, somebody stole the last cookie out of my cookie jar, okay? And my wife told me it was you, Ben, okay? Now, I'm in Connecticut. You believe that. Where are you? What state?
I'm actually in Poland right now.
Okay, well, unless you can tell me who stole that cookie, yeah, I'm blaming you, right? That's ridiculous, okay? We, Globers, think they know everything, right? Flat Earthers know that we don't know everything, right? I can't prove who stole the cookie, but I pretty much can prove it wasn't you. All right. So keep that in mind. So this is what you get. I'm just going to go over some real quick things. The basic Flat Earth 101, right? So when you Google Flat Earth, this is what you get, and that's false binary. Nobody believes in any of that. When you go up, just the highest we can send balloons up 127,000 feet. That's about as high as we can get. And first, the Earth turns white at that height because the colors are muted. The atmosphere is just, there's too much atmosphere to see through, and the Earth is white. Not these Technicolor pictures that the liars at NASA give us. And tell me about the sun. Let's say it's your first day on Earth. You know nothing. You've been taught nothing. Is that sun right there, like over this bright part of the land, or is it 93 million miles away? It's right there.
Yeah.
What is it? I don't know. Got some theories. I think it has to do with our consciousness, but it's just right there. It's local. It ain't much higher than this balloon. Wait a minute. How could it light up enough for the world? We can get into that. How we see all that. Flat Earth is not difficult, but it's a hell of a lot more difficult than just believing what you're told, right? If you wanted to find out where I live, you can go on my Facebook. You can look at my friends. You can kind of look at them. You could look at the metadata on some of the pictures that were taken. You could find my high school. Oh, yeah. You know what? I think he is in Connecticut. So you'd be 99% sure. You're never going to get to 100 because maybe I faked all that stuff, right? You also get this meme, right? But nobody thinks this, that are we the only pancake planet? Again, two false models in one, making you give up. That's what they do. They give you a lot of neurolinguistic false binaries where, hey, if this then that, if that then this, and both of those are not the truth. But you think those are the only choices, right? Hey, vote left, vote right here in America. Both are the same monster, all right?
Yeah. And one of the things that for me, just before we go too far past the sun there, and I'm sure we'll be going a little bit all over the place. We'll do our best to stay in track here. But to me, one of the things that really sparked my curiosity about the sun was, I'm not sure if you know this guy, Holistic Health Nut on Instagram. He curated a bunch of videos and photos photographers took of the sun, where they used the Nikon P1000, which is a very powerful lens. They were literally zooming all the way into the sun, seeing little specks of detail on it. Like you could see it in perfect detail.
Sunspots.
Yeah.
Have you ever seen a real video of our sun, which is supposedly 93 million miles away, 109 times the diameter of planet Earth, and roughly 333,000 times the mass of Earth? Now tell me how we can calculate the mass of the sun if it's 93 million miles away. And did you know that NASA said this is a real image, but it's actually a conglomerate of CGI garbage compiled together based off of data that they've collected? They're just saying that it's not a real image, but they're trying to claim that it's a real image through a bunch of legalese. This is a real image of our sun. It doesn't look like a giant ball of gas and fire. It actually looks pretty local because it's being zoomed in on with a Nikon P1000. Now, I'm not really sure how a Nikon P1000 can zoom in on something that's 93 million miles away in such great detail.
You could not do that if this thing was 93 million miles away.
We'll get into
how many miles away.
93 million miles away, by the way, is literally arm's reach away compared to the other distances that they're telling us. It is absolutely crazy. Just for example, a trillion is nothing in cosmology. How long do you think a trillion seconds has been? Have you heard me talk about this?
I don't even know. Is that like centuries or something?
So a trillion seconds. Take a guess how long it is. 1 trillion seconds.
5,000 years. No idea.
That's not bad. 31,000 years. Okay, that's a good guess, though. Most people go like 4 years. 31,000 years. And they tell us things are hundreds of trillions, quadrillions of miles away, and we could see them with our naked eye. It is the dumbest crap ever. here's just got two windows at the end of this flat hallway. We know that hallways are flat. And then we got this light here at the end of the water. You wouldn't see a line like this if it was humped. It would just be one specular highlight. The argument there is, well, the Earth is so big that it looks flat from where you are. Cool story, bro, right? Cool story. They teach us that we're all orbiting the sun, all the planets, but they don't teach us that the sun is flying at 500,000 miles per hour in the heliocentric model. So we're spinning at 1,000 miles an hour at the equator, 1,000 miles an hour. That means we're dropping at a mile a minute. So don't tell me you wouldn't feel that at that curve. You know, hey, if you're in a car going 1,000 miles an hour in a straight line, you could argue, or an airplane, that that you might not feel it. But as soon as it takes a little bit of a turn, you're gonna feel it. So we're spinning at 1,000 miles an hour, orbiting at 66,600 miles an hour, funny number, average. Then we're chasing it at 500,000 miles per hour, and this entire system is moving sideways at a couple million miles per hour. But none of the stars ever change. In all of history, all of the zodiacs are all the same, right? So this is just to give you an idea of speed. This is NASA's hypersonic sled to rocket sled. Watch, it's going to go by at Mach, can't even see it, Mach 8.6. Now, if you look up hypersonic sled track, you'll get this exact video and you'll hear it. The sound is literally shocking to every cell in your body, right? Watch, Mach 8.6. If you believe in that model, well, if you're a glober, you have to believe in that model, that we are orbiting the Earth, right? So we're a lumpy rock surrounded by curved, smooth water that no one's ever seen the curve, surrounded by high pressure air, adjacent, without a container, to a void called space of no pressure, right? Air needs to be contained. Well, gravity is holding onto the air. I'll prove that wrong in a little while. And that is moving around the sun. Ready? Can you fathom what twice the speed would be? You can't, right? It's going around the sun 10 times faster than that and chasing the sun 100 times faster than that, right? But when you go out into nature on an early morning, you could see stuff like this.
I'm a big fan of rock balancing. I stack those rocks out in
Cairns,
nature.
yeah, I do too.
It's perfectly balanced.
Yeah. So you can go out and see that these are perfectly still, but we're doing all of this. All of that. Does that make any sense whatsoever?
Now, Dave, but gravity though, this magical
gravity.
force, this magical force, this blanket around the Earth that is so strong that holds every single skyscraper down like glue, but is instantly conquered by a balloon. This is the thing that's interesting to me, is that no matter how many of these pictures you show them of like the super stillness and Jenga towers and things just looking so still, they will say, oh, gravity. Gravity is like the thing that you always get back as, I don't know about gravity the more I think about this, because you talked about how, they'll give the example of when you're on a bullet train or something going 200 miles per hour, you don't feel it, you can walk around. That makes sense. That's a single directional vector, though. We're talking about 6 different directions going infinitely fast, and the explanation is that makes sense because gravity, but I just don't know. That sounds like a lot.
If you fill a balloon with helium, a substance lighter than the nitrogen, oxygen, and other elements which compose the air around it, the balloon will immediately fly upwards. If you fill a balloon with hydrogen, a substance even lighter than helium, the balloon will fly upwards even faster. If you blow a dandelion seed out of your hands, a substance just barely heavier than the air, it will float away and slowly but eventually fall to the ground. And if you drop an anvil from your hands, something much heavier than the air, it will quickly and directly fall straight to the ground. Now this has absolutely nothing to do with gravity. The fact that light things rise up and heavy things fall down is simply a natural property of weight and density. That is very different from gravity. Gravity is a hypothetical magnetic-like force possessed by large masses which Isaac Newton needed to help explain the heliocentric theory of the universe. Lady Blunt says, most people in England have either read or heard that Sir Isaac Newton's theory of gravitation was originated by his seeing an apple fall to the earth from a tree in his garden. Persons gifted with ordinary common sense would say that the apple fell down to earth because, bulk for bulk, it was heavier than the surrounding air. But if, instead of the apple, a fluffy feather had been detached from the tree, a breeze would probably have sent the feather floating away, and the feather would not reach the earth until the surrounding air became so still that, by virtue of its own density, the feather would fall to the ground. Wilbur Voliva, a famous flat earther in the early 20th century, gave lectures all over America against Newtonian astronomy. He would begin by walking on stage with a book, a balloon, a feather, and a brick, and ask the audience, how is it that a law of gravitation can pull up a toy balloon and cannot put up a brick? I throw up this book, why doesn't it go on up? That book went up as far as the force behind it forced it, and it fell because it was heavier than the air, and that is the only reason. I cut the string of a toy balloon. It rises, gets to a certain height, and then it begins to settle. I take this brick and a feather. I blow the feather. Yonder it goes. Finally, it begins to settle and comes down. This brick goes up as far as the force forces it, and then it comes down because it is heavier than the air. That is all. David Wardlaw Scott says, any object which is heavier than the air, and which is unsupported, has a natural tendency to fall by its own weight. Newton's famous apple at Woolsthorpe, or any other apple when ripe, loses hold of its stalk, and being heavier than the air, drops as a matter of necessity to the ground, totally irrespective of any attraction of the earth. For if such attraction existed, why does not the earth attract the rising smoke, which is not nearly so heavy as the apple? The answer is simple, because the smoke is lighter than the air, and therefore does not fall but ascends. Gravitation is only a subterfuge employed by Newton in his attempt to prove that the earth revolves around the sun, and the quicker it is relegated to the tomb of all the Capulets, the better will it be for all classes of society.
Gravity was originally thought of by Freemason Sir Isaac Newton, who claimed that instead of objects falling due to density, rather they fell due to a mystical pulling force in which a smaller object can be pulled or attracted to a bigger object. Of course, gravity can be observed nowhere in nature, and scientists claim to have recently discovered gravitational waves, yet they still can't even prove it with experiments. Gravity also seems to be fickle and selective, and not only is it a force that pulls objects to the center of the spinning ball Earth, but it is also a force that allows heavenly bodies such as planets to orbit around bigger bodies. How is it that a force can be strong enough to hold oceans, buildings, and people stuck to the Earth, yet just weak enough to allow bugs, birds, and planes to fly freely in every direction. How is it that gravity can keep the oceans from flying off into space, but weak enough not to sink a sailboat? We are also told that gravity is what allows moons to orbit planets and planets to orbit around stars. Either gravity should cause people to stick to the Earth, or it should cause people to orbit the Earth. It should either allow the moons and planets to crash into the sun, or it should cause planets and moons to orbit the sun. Both functions are clearly different. The natural world around us was explained by the laws of density and buoyancy, in which objects fell due to being denser than the air surrounding it, or being less dense than the air surrounding it, so it rises like a helium balloon. Density and buoyancy are the only reasons why objects fall or rise, and gravity can be found nowhere in the natural world and is a hoax.
They place the truth in plain sight and weird places. Number one is a Galileo thermometer. So Galileo laid the foundation for the theory of gravity, and his thermometer works off of density and buoyancy. Each of these little ornament things are filled with a slightly different liquid, and they respond to the temperature of the medium that they're in. Next one is a basic hand boiler. All you have to do is hold it, and all of a sudden, all of my liquid is at the top. Is my hand boiler anti-gravity, or does everything work off of density and buoyancy? When the gas expands in the bottom, it pushes the liquid up to the top. Then I have an anti-gravity bird that plays on density and buoyancy by weighting the bird a very specific way. Does my $3 toy have an anti-gravity machine, or is the theory of gravity wrong? On top of the fact that it's been proven wrong over and over again, it's in our faces. Basic observations of your environment and things like this tell you the truth about it.
So, do you guys remember when Neil deGrasse Tyson said this weird thing about gravity?
Is gravity?
I have no idea. Okay, next question.
Wow.
No, here's the difference. We can describe gravity. We can say what it does to other things. We can measure it, predict with it. But when you start asking, like, what it is, I don't know.
So did I accidentally ask a deeper question than I meant to?
Yeah, no, you were meant to ask deep questions.
Apparently I was.
In life. So, to say, what is it? I think Einstein, in an Einsteinian answer, we would say gravity is the curvature of space and time.
Oh, right.
And and objects will follow the curvature of space-time, and we interpret that as a force of gravity.
Oh, yeah. Dude just had to say curvature. So, gravity is the curvature of space and time? Why don't you just look up gravity? It's actually a theory, and there is no way to prove it or measure it, but we can observe it. But we cannot observe it in the microcosm. Nowhere on Earth do we find large rocks forcing small rocks to orbit around them, but we see it in our solar system, which is all CGI.
Telling you gravity really is the curvature of space and time. That gets us the Big Bang and everything we've ever known and
curvature of
loved.
Space and time, but it's also based on mass, right? It's based on the amount of mass.
Any
an
concentration of
object
matter and energy will curve the fabric of space and time.
has. And the more mass,
and
the
the
more
movement
gravity.
of matter on that fabric of space and time, we call gravity. And I'm good with that.
Okay, but you seem a little oddly defensive about something that's scientific.
No, I have to say I'm good with the.
But you are, because you're kind of defending it.
No, you can say, well,
Defending,
why does matter?
Why do you need to know why?
No, why
That's what you're saying.
No, I'm saying, why does matter and energy curve the fabric of space and time? You can ask that.
Okay, why?
And I don't have an answer for that. I can say,
Well, that's all I'm asking.
when someone goes, well, gravity's holding the air down, I say, which gravity? Like, what do you mean, which gravity? They don't even know that there's two gravities. There's Einsteinian gravity where an apple fell on his head and he goes, oh, gravity. But thank God a kid wasn't walking by and let go of a helium balloon and the apple rolled down the hill and fell into a pond and started floating, because then what's he going to think? Right? That could have ruined this whole theory of gravity. So they've thrown out the gravitational model because it's 96% wrong. Right? They look at the gravitational mass attracting mass model. It's 96% wrong. If you had a theory that every car that you're sitting on a busy street, that every car that went by was going to be a red car, but you only got like 4 out of 100 cars that went by as a red car, how's your theory doing? Right? But instead of throwing out the theory, they said, well, we'll just add 96% dark matter and dark energy. No one's ever seen it. No one's ever measured it, but it's got to be there because gravity, right? This is the bullshit that they put out there. And so you say gravity, and so then they say, well, the bending and warping of space-time is Einsteinian gravity. They changed it to that. You've heard that, the bending and warping of space-time, right? Have you heard them talk about that? That's a yes?
Yeah.
Right?
All these things that are told to us in school that really are just, they sound like nonsense when you think about it from a first principles, but since you're told it so young, it's like, okay, that's just how it works.
You have to believe it because you're a kid. You don't have the discernment. But do you know what the bending and warping of space-time is? And the answer is no, you don't, because nobody does, because it's stupid. It's literally the bending and warping of your mind, right? And they just say this shit, and a guy's got a white lab coat and a pocket protector with a whole bunch of pens in it. Therefore, you have to trust him because you're just a little kid, right? They teach you the gravitational moon orbiting the Earth and the sun, Earth orbiting the sun in kindergarten. Why are they teaching you that? Because it's the foundation of your worldview. It's the foundation of your worldview, right? They say flat earthers are crazy because we think down is down for everybody on Earth. We think down is this way. Point down. You're in Poland, right? It's the same down. It's the same. It's not like that. It's not like that. Down is down. Well, gravity's holding us. Down is down forever we are because down is towards the center of the Earth, right? But we're crazy because we're stationary and down is down. But this is spinning, okay? And down is down for each of these people. Now think about this. If it's spinning 1,000 miles an hour, curving at a mile per minute, you're going to have some force. So the guy on the equator, he's going to feel tall. This guy is going to constantly be leaning over, right? Because think about the spin. This guy's going to be pirouetting like a ballerina, so he's not going to have any force. That's just the spin of the Earth. Forget all the other motions, right? So that is incredibly crazy. So great MIT professor Walter Lewin says it's electric forces that hold our world together. Okay, can we test that? Can we test that? Sure. So so the Earth is testably, measurably, scientifically provable. The Earth itself has a neutral or negative, depending on how you classify it, charge. And the sky has a positive charge. Okay? Anything you pick up off the ground is now surrounded in a positive charge. The ground's not moving. This is more dense than the air, and it goes down because the positive and negatives attract, which just sets the downward force. It's very weak. And then the buoyancy and density sort everything else out. If I had a balloon, a helium balloon, it would go up because it's less dense than the air around it. Okay? And we'll get into that in a second. So I got some leftover helium balloons here, and we tied it. There's a little button here, and it's about 2 inches off the floor. This wire goes to a Van de Graaff generator, which can add a positive charge to things. So we're going to add a slightly higher positive charge to this. And it goes down. Now, did we make it more dense, or we just made it more positively charged? And then when we discharge it, it goes back up. So that's a way to manipulate the electrostatic charge and test it scientifically. So, hey, we just manipulated it. Can you manipulate your globe? I can add a negative charge into this. I can turn it off. It goes back down. I turn it back on, keep it on. It stays up. So, again, we're manipulating the electrostatic charge. So we know that that's real. Maybe gravity's real also. This is, again, at MIT. They created the silent drone. It looks like a bunch of milk crates or a skid. No moving parts, and it flies. And they can lift and propel it. There's in America here, we have the XRT-3 triangular aircraft, and they admit, they declassified that it lifts and propels itself with electrostatics. How come we don't have cars that do that? How come they're not sharing this technology?
Hello, everybody out here in YouTube land. Good times for all. There's Zachary Zabal here if you prefer. In this video, we're going to be talking about the phenomenon known as gravity. What I have here is two pizza trays. I'm just trying to get it focusing on that little piece of paper up there, but it's not going to happen. But you saw it sitting down there, now it's stuck to the top. See that right there? That is our test subject. Whoa. Alright. As long as I apply a current to that, that'll stay there. As long as I keep turning this thing, it'll stay up there like that. Now all I've done is I've applied a positive and a negative charge, one to one of the plates and one to the other. And as you can see, instead of being positive and negative like we are here on Earth, with the negative on the bottom and the positive on the top, I've reversed it. And it sticks to the negative, just like here on Earth. Now I know there's a lot of people that don't like saying the word gravity, but there is a force. It is not Newtonian, it is not Einsteinian, but there is a force that is creating this, up and down, which tells denser objects which way to go and makes relative density work. And it's just all electricity. That's all it is. Just like everything else around here. Every chemical reaction, every fire, every sound, everything is electricity vibrating. And it'll just stay there, folks. Anti-gravity until, now watch this, I'll discharge it. Boom, boom. There you go. A little bit of electricity stuck in it. Now what it's doing is called induction. Whoa, and there we have it. But all I had was the Van de Graaff generator running to the bottom plate here, and the discharge wand running to the top plate. And what you just saw there was a manipulation of the electric field. Kind of like being between two capacitor plates. And there's a flow of energy that happens there. And this is what we call gravity. It's okay to call it gravity. It's the only way people are going to understand what we're talking about. But we just redefine the word. It's It's not Einsteinian, it's not Newtonian. This is not my idea. I don't know who gets the credit for this, but there is definitely a force. And it's okay if we call it gravity, but it has to do with electricity between two charged, whatever you want to call them. So that's it. Good Times for All here signing out. As always, thanks for watching.
This is what they tell us. The electrostatic force is 10 to the 36 power. That's 1 with 36 zeros stronger than gravity. Let's pretend gravity is real. Okay, remember how long big a trillion was, right? So if I came to Poland and I punched you in the shoulder, just a punch like that, you go, ow, stop it. If I punch you 10 times harder, you'd get pissed. If I punch you 1,000 times harder, probably break your back.
Your body
right?
liquefies.
Yeah. And so 1,000. Let's say I did it 1,000,000 times harder. You're dead. You probably destroy the house. I don't know. Depends on how hard I hit you the first time, right? 1,000,000,000 times harder, you'd explode instantly, right? 1,000,000,000,000 times harder, I don't know. You might. I can't even fathom. That's 1,000,000,000,000. Okay. That's 12 zeros times 1,000 times 1,000 strong. That times 1,000 of that. That's 18 zeros, right? We got to get to 36. So what they're telling us is that gravity is zero, absolute zero. They're admitting that what we can play with is 10 to the 36 power stronger than gravity. What are they telling us? Gravity's BS. There's nothing to it.
Mm-hmm.
I got this ball here. Let's say I snap my fingers and the entire world disappeared. And it's just in space. If I let it go, where's it going to go?
It's just going to float there, right?
I don't know.
There's no more gravitational
Well,
thing,
it's not gravitational. There's just no electrostatic force anywhere. There's nothing to tell it which way density will take it, right? So there's an electrostatic flow into the Earth. It's buoyancy and density that sort everything else out. Because I just manipulated the electrostatic force and made this thing go up. Where's gravity? Is it fighting the electrostatic force? It can't. It's 10 to the 36 power weaker than the electrostatic force. And that's from the globalists that say that, you know? And they also say things like, you know, the theoretical physicist Michio Kaku says that theoretical, you know, astrophysics is off by 10 to the 120th power. That number doesn't even exist, right? That number is so big that the human mind can never fathom what it is. So,
and I think that more people are open to this idea that the official authorities and the scientists that feed us a lot of these facts or non-facts. That's the problem. We think they sound official and factual because they're coming from a person with a lab coat. But the more of these rabbit holes we go down, learn that they're really just wrong about everything and pay it off and promoting a narrative.
Well, and they might believe it themselves because they're just, you know, a degree doesn't make you smart. It makes you indoctrinated. Ben, how do you get a degree? Very simple. Memorize.
By going to school and answering questions correctly.
Yeah, well, correctly. You mean what's in the book. Memorize what's in the book.
Yeah.
And then regurgitate it. Now, do you get a PhD if you question everything that's in the book and come up with different theories? No. You get thrown out of school. School is literally indoctrination camp. Now, there are some things you can learn. Like, you know, people say, you know, Dave, you know, I'm way into alternative health and stuff. There's nothing allopathic medicine other than maybe an occasional Advil that I will ever use. And the point I forget the point I was making. The point is they'll there's like, if I got run over by a truck, I want to see an orthopedic surgeon. You got to go to school for that. That's real stuff you can study. But like pharmaceutical medicine, it's all nonsense. It's all absolute and total nonsense. So what I'm showing here, this is the toroidal field. We live in like this double toroid, and then this plane in the middle, this dielectric plane, which we can recreate with toroidal fields. This is the plane of existence. This is where physical real world lives. I say it's 1% of the whole system. And that's what we're talking about today, this 1%. All of this rest is non-physical, spiritual, and we got to, we can't measure it. We can't test it. There's nothing. So it's just this 1%, this dielectric plane that we're talking about.
So one of the things that we sort of grazed over that I'd really love to dig into right now is the stars. Because
the stars.
We talked about how, so the heliocentric model, which is the one that's taught to all of us since the second we are born, basically, we see the globe. We're taught about all these spinning motions everywhere that are happening. The thing that, for me, this is one of the first things that really got me thinking is, okay, does this actually make sense? And I pulled up a picture that I think puts it well. So if I could do a real quick screen share here. This meme pretty much says it all to me. I mean, according to the model that you showed us, where we're spinning in 5 different directions, 1,000 miles around on the Earth, 66,600 miles around the sun, 500,000 through the galaxy, 2 million through the universe. All these things are happening at once. How the heck, for 6,000 plus years of recorded history, the stars are the exact same in the sky, and they just keep spinning around the same North Star? That to me is okay, something's a little bit weird about this. That doesn't pass the common sense test to me. And I think that, and as you have there, you have your own, just a picture of what the star is actually using our eyeballs, which is, I think, something that more people need to start using, because even with our naked eye, we can see stars appear to twinkle. We have this song, Twinkle, Twinkle, Little Star, and they're different colors twinkling. There was one that I could see out my window when I was in Costa Rica recently. I'd go outside and just look at the stars, and it was very beautiful there. There's very little light pollution. There was this one star right above the trees that was blinking
Arcturus,
red,
and it was very very colorful, right? Very colorful. And that's an amazing one. You can see it with your naked eye. It is wild.
Up here are 2 videos of the sunlight shining through water. And down here are videos of real stars and planets captured from a Nikon P1000. Now, doesn't the Bible always say this one thing? The waters above? Now, I know a lot of people say the Bible is just a bunch of archaic mumbo-jumbo. But let's read this. And they that be wise shall shine as the brightness of the firmament, and that they turn many to righteousness as the stars forever and ever. So not only does it mention the firmament, but it says that the stars are turning forever and ever.
All right, I want to show you guys something here. This is actually a star. This is a close-up of what a star really looks like. under a very high-powered zoom camera. Now, I just saw this video and I want you guys to see this. So check this out right here. Now watch this. So Buddy's just literally flashing his light on a, bowl of water here. Look at this. Look at the reflection. Water. This is what it is. This is quite literally what the stars actually look like. All of these. Now, what's interesting about this is all of our ancestors told us that we live under a firmament and that there is waters above this firmament. In the Bible, this is mentioned many, many times. And God said, let there be a firmament in the midst of the waters and let it divide the waters from the waters. It's as above, so below. The stars are all frequencies of light within the waters above the firmament, just like we've been told by all of our wisest ancestors. Stop listening to fucking NASA. They are just deceiving humanity and hiding God's true creation. You need to look within for the real answers.
Okay, I'm going to show you with a bowl of water and the sunlight how the stars and planets reflect through the firmament. Now let's have a look at the stars and the planets through a real telescope in comparison to the demonstration I just performed. Now, like the Bible says, the stars are fixed in the firmament. So there you have seen it. Simple proof that the stars and the planets are nothing more than the sun reflecting through the glass firmament and the waters above. Thanks for watching.
Scientists managed to create a star in a jar by putting water in an empty vacuum and then passing a sound wave through the water. This causes the water to expand in the middle, creating an air bubble, and then the water collapses upon itself. And the intensity of this collapse is so powerful that it generates heat and light, creating an artificial star. Now, Nikola Tesla told us to think of the universe as energy, frequency, and vibration. Energy is light, frequency is sound, and vibration is the effect of the sound wave passing through physical material. The entire universe is light, sound, and vibration. Now, how are we able to create an artificial star? By putting a sound wave through a vat of water. Now, the Bible speaks of the waters above. Now, I know we say that space is an empty vacuum, but what if space is pressurized water? Because in the beginning was the Word. Now, even animals and life on Earth uses light and sound communication to communicate with each other. Because micro to macro, we are the stars. Man is the measure of the universe. Everything is connected in every single way that you could possibly imagine. This is one beautiful creation. Just look into the study of cymatics, and you will look up at the stars and think much differently about them.
We can talk about the official narrative as, oh, it's distortion from space. And like there's so much atmosphere and things that it distorts it. And so what you're seeing is not actually what you're seeing. It's distorted.
That's what they want you to believe.
This is all that anyone's ever actually seen.
Well,
so how do we know it's something different?
We're going to put that to rest in just a second here. So two things to talk about. I want to talk about the first one. You talk about the spaghetti star trails that we would see. So do you know what's the only star in the sky that doesn't move?
The North Star Polaris.
The North Star Polaris. It actually does move. It makes a tiny little circle, but it's in the same place, right? And it's there day and night. Now, is Polaris, according to the heliocentric model, a special star? Because if the Earth was tilted somewhere else, it would just be a regular star that would circle around the other point of axis. So let's pretend that there's other people on other planets. Is Polaris an important star to them?
It shouldn't be.
It shouldn't be, because their axis points are pointing in different directions. So not the scale, of course, right? So here we are. Let's say Polaris is up there, right? That's our axis of rotation. What if we were tilted that way? Well, Polaris would be out and it would rotate around what's over here, okay? And the other planets, this one, maybe its axis is up here. This one, maybe its point is out there. This one is over here. This one's over here. So they'd all have their own North Star, right? Makes sense. We're taught that we all circle around the sun, correct?
Yeah.
So why is it that all planets all circle around Polaris in their spirograph patterns? All of them. This is Juno's asteroid. Polaris, 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 Polaris. Polaris is in the center of all the rotations of all of the luminaries in the sky. There is no heliocentric explanation for that. And the way they get away with it is the people that believe in heliocentrism don't even understand what I'm saying right now. They can't fathom it because they were never taught to think. They were only taught to memorize and regurgitate. It's sad, right? Your brain has atrophied. If the longer you're in school, the more it atrophies. And you get stuck into this memorization, regurgitation. Like, you know what? I'm going to go work in corporate America and I get 2 weeks vacation every year, right? And they're going to pay me during that vacation. This is great. Right? I'm going to pay for electricity, which should be free because it's everywhere. I'm going to pay for food, which anyone can grow anywhere. Okay. Right. You have no idea what this place is. And we're brought into this mentality of just literally being a slave on a plantation. And we don't even know we're on a plantation because we're stuck on a friggin' ball.
Okay, if you still think we live on a globe, I really want you to pay attention to this video. This is the planet Venus traced in the night sky over an 8-year period. Every 8 years, it does this mathematically precise, sacred geometric pattern on repeat into infinity. Now, this is why it does this. The planets are the only wandering luminaries in the night sky, and this is the path that they take. So they just keep on rotating in this beautiful flower of life geometric pattern until they create this perfect sacred geometry over about an 8-year period. Okay, now check this out. If you point a camera at Polaris, the North Star, which doesn't move, by the way, and time-lapse it, you'll notice that the stars do perfect circles around Polaris to infinity. The ones closest to Polaris are going slower. The ones further away are going faster. Now, the 8 planets, which aren't physical objects, I'm going to prove that in a second, they are the only wandering luminaries that don't follow this transit. Now, this is what Venus actually looks like. Does this look like a physical object to you guys? When you take a high-power zoom camera and zoom in on the planet Venus, this is what it actually looks like. They are wandering luminaries, just like all of our ancestors told us. This is what Mars looks like. Again, does this look like a physical object to you guys? There's a big difference from what we see and observe with our own 2 eyes to what NASA's CGI bullshit is telling you. And here you're gonna see Neptune. Again, this is not a physical planet, guys. They are frequencies of light within the waters above. It's as above, so below. And this is exactly what the stars really look like, guys, when you just zoom in on them. That's all you need to do. This is exactly what it is, guys. This is what all of our ancestors told us. What does this look like to you? It's frequencies, it's sound within water. That's what it is. Now I'm going to show you what cymatics look like, sound frequencies when they're pitched into water and they use a light. Look at this. It's the exact same thing, guys. This is what it is. This is exactly what you are seeing right here. These are cymatics. It's all sound and frequency. The truth is right in front of your face. You just need the eyes to see. I am telling you. I am telling you this is what it is. Stop believing the lies that your predecessors want you to believe. They are hiding God's true creation. This is what all of your ancestors tried to tell you. This is the wisdom and information that they passed along. The firmament, the waters above the firmament, the waters above, the stars on the firmament. Literally every single one of our ancestors all told us the exact same thing. It's right in your face. And the real truth to everything is found within us all. Peace and love, guys.
So let's use some analytical thinking here, some simple logic. Star trails quite literally prove and show that all of these stars rotate around Polaris, and also all of the planets appear to rotate around Polaris. Now, how would it appear that all of the planets appear to rotate around Polaris if supposedly the Earth and all of the planets are rotating around the sun? Does that make sense? And how come this dude that went way up into the sky in his little airplane can see the sun and the moon at the same time over a seemingly flat plane? Is this an optical illusion? Is this refraction? Or is something else going on? Perhaps the sun and moon are much smaller and local. Perhaps they're the same size and rotating around over our flat plane. Perhaps Earth is all of the physical universe, and outside of Earth is nothing. So the universe is the cosmic egg, the torus field in which we live, and the astrological signs are the 12 star signs that rotate overhead year after year.
And we could talk about this later. This is sort of a later topic of why would they lie about this? Like, what do they have to gain from this? Why does it matter? the things that people always eventually move the goalpost to once you prove enough of their points wrong. And it really just comes down to, it makes you feel like an accident. If you're just out in the middle of the universe and there's an infinite space everywhere, I don't know where I'm going with that, but it is a big question. I mean, what do you say when people ask that question? Why would they lie about this? What did they gain from this?
That is the big question. That is my favorite question. We're going to get to that after we look at more
let's hold that for later.
Yeah, let's hold that because like I always give this horrible analogy. You walk in a room, there's a whole bunch of people that look like they've been murdered with axes. There's that bloody axes all over the room, and you look around and go, "Why would anybody do this? What's the motive?" I don't believe it. I want to show you the dead bodies first, right? And then we'll talk about the motive.
Yeah.
Okay.
I agree. Right?
We'll talk about the motive. So what they did is they took the azimuthal, this is the AE map. This map was in all schools, all encyclopedias, right? Here's Australia, South America, right? We're here. This is Antarctica. It's the shoreline around our world. Large bodies of water at rest need to be contained, and at rest they lie flat, right? If you had a bathtub and the side of the bathtub was missing, you don't have any more water. Right? So a pond, the shoreline of the pond is higher than the water. A lake, it's higher than the water. The ocean, the side of the ocean, it's like a giant pond, has to be higher than the water. If you took the average elevation of all the continents, including Antarctica, Antarctica is over twice the elevation of any other continent. Bet you didn't know that. And so that is the container of our world. What's beyond there? We can speculate all day long. I love speculating about it, but we do not need to speculate what's beyond 60 degrees south, where we're not allowed to independently explore. And that's another weird thing. All the countries in the world agree that no one's allowed to independently explore Antarctica or the North Pole. Why? They'll let you climb Mount Everest, freeze to death, and be there as a tourist site forever. But they won't let you go to Antarctica. They won't let you freely explore Antarctica. So what they did is they took this, they cut out the map, right? They cut out the map and, hold on, let me get that going. They cut out the map and then they wrapped it around a sphere and they said, you are not allowed to explore this white area because there's penguins there and ice and we don't want to pollute it, right? So this is off limits. Now, there's a whole bunch of bases here, here. There's all these bases along here. They claim there's one here, but there isn't. And they're all along here, right? So, and no one is allowed to independently explore. But so now, let me go back to here to show you easier. So here's the Flat Earth. This is my Flat Earth clock app that teaches you all about Flat Earth, helps you teach everyone else. You can find it at flatearthdave.com. We'll talk about that later. But if I go to the images section and I type in Antarctica, I think that'll do it. And these are, so here is, I'll make it a little bigger. So here's Antarctica and all these red dots. These are the bases, the alleged bases. Right, so here they are plotted out on a flat Earth map, on a globe map. But if we go here, this is what it looks like. I'll just zoom in. This is where they are on a globe map. On a flat map. I'm just dyslexic. On a flat map. These are all the tourist sites over here. The one place that they'll take you without no problem if you have $30,000 or $40,000 to go for 3 days is an island called Deception Island. Or you can go to the island next door, which is called Rothschild Island. I don't know why they named that, but it's fascinating. And so that's how it looks. We're talking about stars. Let's not get off the stars. So stars are very interesting. I showed you that one. Where is? There it is. All right. So when we look up in the sky, we can see the star Sirius, which is a nice big star. And then we can see the star Orion, which is smaller. All right. And then we get our P1000. We can zoom it in and we can almost make it fill the entire lens. It's pretty big. Pretty cool. Right. We can do the same with Orion. almost as big. All right, so now check this out. Let's say I was zooming in. We're on a giant flat area, right? The salt flats, and you were 5 miles out, and then your friend was 10 miles out. Could I zoom your friend as big as I could zoom you? No, I can't because it's too far away, right? Sirius is 50 trillion miles away, okay? A number you can't even fathom, right? Orion is not twice that, 10 times that, 1,000 times that, 1,000,000 times that. It's 52 million times farther than Sirius. So for me to be able to zoom it in the same size, it would have to be 52 million times bigger for me to be able to zoom it in. If you could even fathom that you'd be able to see the light from it, it's all nonsense. Once you understand what the inverse square law of light is and how light spreads out over distance, the farther the light goes, the more it spreads out. Imagine blowing a balloon up to a foot wide. You got good, thick balloon. And then you blow it up to 10 feet wide. How thick is that rubber? Blow it up to 100 feet wide. Blow it up to 1,000 feet wide. Could you even see the rubber? Light does the same thing. Light spreads out. If it's traveling forever, which I don't believe it does, it inversely gets weaker and weaker. So we couldn't see these stars because of the brightness issue. We couldn't see them because of the size issue, right? Our sun is 93 million miles away. That's what they tell us, right? So if our sun was a yoga ball, right, this big, you guys have yoga balls in Poland, right? Okay. How big would the Earth be? Like a marble or a BB, maybe? Right?
Yeah.
Because they say the sun is like 860,000 miles wide. And so if the sun was a mile over your head, it might look something like this. You look up and all you would see is sun, right? Because you'd be on that BB and the yoga ball would be like a millimeter above your head. And so the whole sky would be the sun. Then we move it 93 million miles away. And due to perspective, it becomes the size of a coin held at arm's length, right? Pretty much, just like we see it. If I doubled the distance to the sun, how much smaller would it be? Do you know?
Should be half, right?
Well, it's half the width, half the height, so it would be a quarter of the size.
Okay.
So now it's the size of like a pencil eraser held at arm's distance. If I doubled it again, so now it's 4 times the distance, it would be like a star almost. 8 times away, let's call it the size of a star at 8 times away. So they tell us 93 million miles is 8 light minutes, 8 times as far, 8 times 8, 64. Let's call it a light hour. At a light hour away, our sun would look like a star. At 2 light hours away, you couldn't see it. Forget the brightness issue, the size, angular size. At 2 light hours away, you couldn't see it. Let's make it 24 light hours away. 24 light hours away, there's no one. Globers won't even argue. You could not see our sun. Its magnitude's too small. So at 1 light day away, our sun would be infinitesimally small beyond the human eye's ability to see it. That's not a theory. That's a fact because we have an angular size limit to our eyes. Could not see it at 1 light hour away. Polaris, they tell us, is 46 times bigger than the sun. They also tell us the sun's 400 times bigger than the moon, 400 times farther. That's why they look like they're the same size. So that's scaling and
that's
variance.
A crazy one. Like that's such an infinitesimally small chances that the sun and the moon are the exact same size.
Hey,
when
man, it's a big universe. It's a big universe, dude. You know, we're just lucky. You know, relax. Okay, so follow me through it. This is easy what I'm talking about, but again, if you haven't learned to think, you might have a hard time following. So if I took Polaris and made it 46 times farther than the sun, so the sun's 93 million miles away, 93 million times 46, put Polaris there, we'd have 2 suns in our sky. They'd look the same size. But remember, we just took the sun to 1 light day away, which is way beyond where we could see it. Let's put Polaris at 46 light days away. Round up, 2 light months away. At 2 light months away, we could not see Polaris. Not a theory, actual scientific fact. 2 light months away. You know how far they tell us Polaris is?
How far?
433 light years away. At 2 light months away, it's way beyond our ability to see it. And they tell us it's 433 light years away. That's 433 light years. And now science is going, you know what? The most important star in the sky, we might be wrong by 100 light years. 100 light years? You don't know what 100 light years is. You can't fathom a number that big. Our brains are literally, it takes years of training to understand what that number is.
David Weiss here. I've been taking Masterpiece for probably over a year, maybe even 2 years. And the detox I feel from it is amazing. I have never felt better in my life. I know that sounds like a lot, but I sleep better. I have amazing dreams when I take it at night. I take it twice a day most of the time, but sometimes I only take it once a day because I forget. But it's definitely an amazing product. And now with the new research they've done where it is literally getting rid of the nanotech in your body, I can't imagine not having any. So there you go. That's my testimony. And I love the stuff, and I'm never going to stop taking it.
This is what they do with cosmology. They make it so big that you can't even fathom. And you don't think about it because it's easier to believe that I live in Connecticut than actually go check.
Yeah. So just make it impossible to check. And it's just the number is too big and too crazy. You just assume that it's true because that's so much easier.
Yeah.
Crazy stuff. I'd love to talk just a little bit more about the sun and the moon, because the reason why I like to focus on these for people as I'm trying to raise these questions up is because these are both things that we see every single day. And as we've both talked about, you and I believe they are much closer than we've been told. And I've done a few experiments with my own eyes, and I'd like to just give
Wait
a quick
minute,
overview
you're
of those.
using your eyes and your common sense to look at the
Crazy.
reality of this world? You don't
know,
believe what the books have told you? That the
Crazy,
Rockefeller
right?
funded textbooks that want you as a good worker and not a thinker? You're not believing that? What are you doing? You're crazy, dude.
That's just nuts. I know. And this is what's so weird when you think about it that way, because that really is what it is. But there's so many things people can you don't even have to go do this right now. You can just imagine this, people. So think about a cloudy night with a full moon out or a big moon. When the clouds are out, you see this ring around the moon. It's like a bright ring of clouds and as soon as you go out just a little bit further, it gets dark. The clouds are dark. And so to me, that says if the moon was really 250,000 miles away, as we were told, it would have a lot of space down to those clouds to light them all up evenly, to illuminate all of them, because clouds are only 1 to 3 miles up max. So how come there's such a small ring of light? Maybe I don't know, something like that.
They're different layers. Different layers. Yeah.
Very few miles compared to 250,000 that we're told the moon away is.
Yeah.
So that picture is perfect. That should not make sense for people. Am I right?
Absolutely. It does not work. And also, you could read by moonlight. Okay? You could read by moonlight. You can drive your car with the lights off if you're in the middle of nowhere and there's a full moon. When does a dusty, dirty rock reflect moonlight like that? Right? This will cast your shadow on the ground. This is midday with a light. I'm standing right next to it, so there's no inverse square law issue. It should be as bright as hell. And like, I'm not getting any light off of that thing. I'm getting an image of it. If I turn the light off, you wouldn't see me. You don't see me. You see the light that's bouncing off of me, but I'm not so bright that I'm reflecting a friggin' shadow on you. Right? The moon is a light. It's not, it's lit up evenly from end to end. There should be a hot spot if it was lit up by a single source light.
And I did this test. I did the infamous crazy flat earther test. These people talking about how they are measuring the temperature during a full moon. And I'm sure you've heard of this one before. People will get an infrared thermometer and have two identical objects, one in the shade and one in the moonlight, and test the temperature. And I kept seeing videos of people doing this, claiming that it was colder in the moonlight than in the shade.
And the wind isn't even a factor right now. It's not even blowing. Are you still recording?
Yeah.
Okay, come on. So this is a thermometer, and it's reading 59 degrees. This is the moonlight. We'll get out of the way of the moonlight. 62 degrees, and this is in the moonlight.
Hold on.
60 degrees.
Okay, I gotta keep it right here to see it.
59 degrees. Now we're gonna move over to the other side of the car where the moon is not on. We're just moving. And we're gonna try this again here. And it's now reading 65 degrees.
Okay, now just move the laser up.
And I'm moving the laser to where the moonlight is shining. And it rapidly drops.
Okay, move it back down.
I'm going to move it back down here. Goes back up.
Jump back up.
65 degrees and back on the hood where the moon is shining. It's almost a 10-degree change.
Okay, here's a video a lot of people wanted me to make. Sounds really crazy. I'm using a FLIR, forward-looking infrared device, and it is an extremely clear night with a extremely bright full moon. There goes a car down the road, huh? You can actually still see the brakes on my tires are a little warm there. So, got a full moon and we've got a shadow. So let's do, in the light of the full moon, 16 degrees Fahrenheit, 16 degrees Fahrenheit, 13, 12, 12, yeah, okay. Here we are in the shadow. You can't see the shadow, but I am absolutely pointing it in the shadow. 22 degrees average, 22, 21, 22. Let's go outside. 18, 19. This is in the moonlight. 20, 19, 19. Also in the moonlight over here. 17, 15, 14. And this is in the shadow right here. Here's the base of the shadow. The base of the shadow, of course, since the moon's been rising, is the spot, yeah, right here, 24, 23 degrees. I'll make sure I'm in the shadow. Yeah, there we go. 19 degrees. 18, 17. Also in the moonlight. So, there you go.
So I did it myself. I went home and I tested this, and sure enough, I put a whole blog post on my blog going through all the data. Every single time I did it, I did 6 different tests. I've switched the weights around. I put them on different ground surfaces. I made sure that the shade source was really far away so it wasn't blocking wind or anything. Every single time, it was colder in the moonlight. So, I mean, what do you do with this information?
Well, there's a lot of ways to do that test wrong. Some people will put a cardboard over the ground, but that'll insulate the ground. So you have to do it where you have something vertical, and there's up to a 10-degree difference sometimes. And you can take a magnifying glass and magnify the moonlight, just like you magnify sunlight and burn ants, as you did as a kid. Don't deny it. I know you did it. Okay.
Of course I did.
All right. And it's colder. It's colder. It's funny. We were bringing this stuff up at the globe.
I didn't even see that one.
Yeah. The Glober.
Now I need to try that next time I'm at home. That's crazy.
The Globers come back like there's no way to do that, right? And then meanwhile, a non-flat Earth channel called Cody's Action Lab, who does all these cool experiments, huge YouTube channel, he pointed out there's a thing called a cold laser. Same thing, cold laser. It literally makes things cold. You can freeze things with it. So, just because you don't understand it doesn't mean that it's not real. And just because you don't understand it doesn't mean that there's not an explanation that's very truthful. The image here, this is just using a FLIR camera. Where's the rest of the moon? Where is it? Where is it?
Because our eyes, when you see that, when it's like a half moon or whatever, you see the blue covering that part, and you just assume it's something to do with the shade or the sky color. But that FLIR camera should be able to see everything. It should be able to see. So where did that half go? There's so much weirdness going on there. And people have already also seen stars through the moon. This has been documented. Right? It's so much weirdness.
The light of the moon is totally different than that of the sun. The effects it has on plants and food is different, and even the temperature is different. In the sunlight, the shade is always cooler than the sunlight itself. However, in the moonlight, it is cooler, while in the shade it is warmer. The moonlight couldn't be reflecting the sun's light, because then it would have the same effects in temperature, but it appears the moon is emitting its own light, and is translucent. The phases are a function of the moon, and it is not a spherical ball of rock reflecting sunlight as we are told, but rather is a transparent, self-luminous disk. If the moon were a sphere, then we should be able to see the other side along with different faces, yet we see only one side. Not only that, but many people have taken images of the moon with stars being seen through it, and in the afternoon, you can see the blue sky right through the moon. Just look at these Muslim and Freemasonic depictions of the moon with the stars shining through it.
Yeah, well, did they see stars through the moon, or was the star in front of the moon?
Who knows anymore?
Okay, so don't you can't make it. We've seen stars in the area of the moon that should be blocked according to the heliocentric model, right? The heliocentric model means that we're seeing a star through the moon, which is impossible. But we saw a star in front of that part of the moon that we can't see. Therefore, it's either in front of it or behind it, or the moon is just not there, or they're at the same distance. We don't know. So we have to be careful on how we frame that. This is a picture from NASA. So we got the Earth there. The sun is above them because look, the sun is shining down. Where's the brightness of the moon? This is 250,000 miles away, and it's brighter than right here. This is two different pictures right here. So
yeah, that sizing obviously doesn't make sense because the Earth is so much bigger than the moon. So how come it looks the exact same pretty much as what we see?
Yeah, there's so many problems with the moon. It's absolutely insane, right? And also when a single source light is lighting something, you have like a hotspot. We have no hotspot on the moon.
Right. And there's so many videos of people testing that. The light should accumulate in one area on it. Mm-hmm.
Yeah.
It just doesn't.
Yep. And yeah. And then also, the astronauts on the moon, they don't see any stars, but from Earth, we can see all these stars. What happened to the stars? And the reason they don't show the stars is because they can't, because we'd be like, no, that's wrong. They can't figure out how to do it.
It would be too hard to fake it because how would you show that perfectly in a different place? Yeah.
Yeah. It'd be too hard to fake it.
And the testimonials that the astronauts gave were different. Like some would say, oh, it was so beautiful. There's so many bright, beautiful stars everywhere. And some of them said they didn't see any stars. So they just didn't line up.
Some NASA actors say that you can totally see stars when you're in space.
Whilst in space, have you ever looked away from Earth into the black void?
Because you can see, because you can see the stars.
Oh yeah,
and pretty much all the time you can see the stars.
It's not a black void. I mean, it's black, but there's all kinds of little polka dots.
There's all the stars there, and the cool thing is about it, you can see it during the day.
Yeah, you can, and there's more than stars. You can see planets. You can see moons.
You see the gas. Magellan clouds of the Milky Way
see
galaxy.
The Magellanic clouds.
Magellanic. See, I just wanted the Magellan clouds.
There's a large one
I didn't
and
want
a small one, right?
Yeah.
And then you can see the zodiacal light.
Whoa!
But the NASA actors from 1969 say that you can't see the stars in space.
We were never able to see stars from the lunar surface or on the daylight side of the moon by eye without looking through the optics. I don't recall during the period of time that we were photographing the solar corona what stars we could see. I don't remember seeing any.
You can see the stars.
Oh yeah.
And pretty much all the time you can see the stars.
I don't remember seeing any.
They're just making crap up. Here's a flat moon, okay, and looking at it, just putting a dome over it, just showing you that the optics of how we see is, you don't know what shape something is unless you can physically touch it, right? For example, we don't know how far. Well, we know how far the moon is because they have a laser reflector on the moon, but they use lasers to figure out how far the moon was before they even went there. Dumbest crap ever, right? So here we have 4 moons. How big are these? Now, these are models. Are they the size of a yoga ball? The size of a golf ball? Ping pong ball? Baseball? Do you know?
No way to tell.
Are they spherical?
You can't tell. You would guess that it would be spherical, but you don't know for sure.
Is this one spherical?
It looks like it. It appears to be.
Well, it kind of does, but it's really just a half a sphere, so we don't know what's on the other side. But I'll give it to you. That looks spherical. You got it. How about this one?
Looks like a sphere.
It does.
They all do.
Yeah. This one's flat. How about this one? Looks like a sphere, right?
Sphere.
Yeah. It's a cup. How about this one?
Sphere.
You sure?
One of the four
All right,
has
it's
to be
sphere.
right. Finally got
Well,
one.
no, you
finally,
know,
we finally got it.
I wanted to redo it with 4 not spheres,
Yeah.
just to get people like
Every
you.
single time it can be like the point is that there's no fucking way to know. Like you just can't know.
Yeah.
And we assume that we know, but then when you start asking basic questions about it, and here's a question about it, how the rotation of the moon is in such a perfect way that we only see one face of it ever. That is weird, and that should
Haven't
be.
you
That's
ever
another
heard of
weird
gravitational locking, dude? The side of the moon that faces the Earth has more density, so the gravity's holding onto it. Okay, this is you know. Listen, I could be a glober all day long. You just make up stupid shit, and that can't be proven. So the Earth is traveling 67,000 miles an hour around the sun. So the moon, when it's in this position, would also have to be traveling 67,000 miles per hour, right? So the moon's orbiting the Earth, so it has to slow down so the Earth can pass it. And it's traveling 2,000 miles an hour. So here, it's going 65,000 miles an hour. And then it comes back here, and it's got to accelerate again, or otherwise it's going to be left behind. So now it's going 67,000 miles an hour. And now it has to accelerate to 69,000 miles an hour to keep its 2,000 miles an hour. And then it has to slow down again when it goes up here. Come on, go. It has to slow down to go to 67,000 miles an hour. What's the mechanism that makes it speed up and slow down? Gravity, dude. Gravity.
Magic.
Magical gravity. Gravity.
And the Earth is doing the same thing around the sun. It has to follow the sun that whole time, so it has to speed up to catch up with it on one half of the journey, and then slow down to get past after one half of the journey.
Isn't it amazing that you got the sun and you got all these planets that are so far out there? They're all on the same plane, right? They're all on the same plane. None of them lag behind. None of them go forward. They're not going like this, like an electrons on a theoretical atom would do. They all stay flat. They tell us that galaxies are flat. I love when Globers go, "Oh, the other planets around." I'm like, "Well, galaxies are flat." They're like, "No, they're not." I'm like, "Go look at your own science." They say galaxies are flat. Well, that's because of the gravitational spinning of the massive supercenter is putting out a gravitation. Bull crap. Absolute and total nonsense.
Yeah. So something I'd like to get into here that we haven't really done yet. I think we've thrown out a lot of good questions people should be asking about the current model. And if you want to go over more, we can.
No. We'll go anywhere you want. Let's go.
So why don't we talk about... Actually, shoot, that picture you just brought up is making me wonder about this too. Just speaking of things that we can look at with our own eyes, how about these extremely long distances that people are starting to go out and go, just look way further than you're supposed to. And we can talk about the curvature math you're supposed to see and how that doesn't add up. You have so many. I'm just expecting you have all these great visuals for all these things now because you just have them everywhere.
If we're here and you walk around the corner here, this is a curved hallway, and I had my P1000, could I zoom in and see you?
No.
I'm going to turn the hallway sideways. So you walked over, now you're down around. Can I zoom in and see you behind this hump, behind this hill?
No,
I can't. So the thing that got me into flat Earth is boats over the horizon. I'm like, I've seen it. They showed me that 3-masted ship in elementary school, and they said, this is how boats go over the horizon. So you got this. So you got my boat here, and it just goes away, and it disappears from the bottom up. Well, if the Earth was a ball, that's how boats would disappear. Very cool. But that's not what happens. On a physical ball, there is a required maximum distance that you can see. Do you know how far what the curvature is at 3 miles?
So the official math is 8 inches per mile squared, right? So you just plug 3 in there? Mm-hmm.
Yeah, so it's 6 feet. So a 6-foot tall person standing at the edge of perfectly calm water should not be able to see the surface of that water beyond 3 miles because it's dropped 6 feet already and they can't see over that anymore, right? So if you could see something beyond that, it doesn't mean the Earth is flat. It could mean the Earth is bigger, but if the Earth is bigger, then every single thing they've told us about space is wrong because everything's based on the radius of the Earth. Okay? So here is, where's a good one? So again, we can't see forever. For example, this mountain here, they're all the same color, but it gets weaker and weaker and weaker. And if it was a little clearer, we'd be able to see another mountain over here. So you can't see forever. So you say, oh, this is my horizon. That's my horizon, right? Same thing. You can't see forever when you're looking across the atmosphere. Now, it's arguably you can see farther when you're looking up because you're looking through very little atmosphere. But, when you're looking up, you're looking through a tiny bit of atmosphere. When you're looking across, you're looking through 100% atmosphere. So I'm looking
is getting
for
more and more thick with haze because they're spraying it with a bunch of heavy metals, by the way. So who knows if there's some connection there.
Climate trails. Keep an eye for it on the Stu Peters Network. So here's the top of a mountain. And again, we have this relatively flat horizon, but the Earth is so big you can't see the curve. That's okay, right? But there's more here, and you lose the information. You lose the information in the distance. The sides ramp in, the top ramps down, the ground ramps up, but the back ramps forward also. And you lose, you can't see the information. Hold on, I got another spot where I can pull this up. Where is it? There it is. So here, this is an example. So here we're looking out. Now, you can't see right here, but there's a little pier right here, which is about, 150 yards away. So from here to here, this reflection, that's about 25, 35, 45 yards, 50 yards, we'll call it, 50 meters, all right? From the edge of this reflection to this horizon is probably 10 miles. So we're losing information as the farther out we look, right? So from here to here is X distance. From here to here is that same distance. From here to here is that same distance. From there to there is the same distance. And it goes on and on and on and on and on until these lines are just stacking on each other. And you can't see what's out there. The same is true. So so here's a side view. No one ever sees a side view, but we got a boat here and we move it there. Let's say it's a mile and it gets that much smaller. At 2 miles, it's that much smaller. 3 miles, it's that much smaller. 4 miles, it just gets smaller and smaller. And eventually, visually, it stops getting farther away and it just gets smaller and smaller and it disappears into the horizon. So you got all of these distances are the same and the sky does the same thing. This distance is the same as that distance, is the same as that, is the same as that, is the same as that. And everything gets crunched into this no information zone or this horizontal eye zone or the horizon, right? So
it's all perspective, essentially.
Yeah,
and this is the thing. If you pull out a Nikon P1000 in this ship that you thought disappeared, you can just zoom back in on it. It's just disappeared from your perspective.
Here is, we got this horizon line out here, and you think, oh, that's the edge of the Earth. So, but when we zoom out, all of a sudden we can see that it's actually miraging. The horizon's out here somewhere, and these are dolphins jumping up. So they're like behind the Earth curve, jumping up, going, look at me, I'm coming up over the Earth curve, right? You can see the water splashing. Yeah, you can see the water splashing where they are. So that's not Earth curve. This is just a mirage of the sky. And that's what happens over distance. When over distance, the air becomes opaque and you can't see beyond it.
Would you believe me if I told you that the sun doesn't actually set, but the sun is just moving further away, and it's moving away from our visual horizon? Because the horizon line is actually just a visual horizon. Our ocular nerves perceive light only so far, and everything collapses into one focal point. So anything beyond that you can no longer see. This is why it appears that streetlights are disappearing below the curvature, but in reality, on a flat street, you can clearly see that there is just a vanishing point where all parallel lines meet into one single focal point, and then beyond that focal point you can no longer see. However, if you take a high-powered camera or binoculars, or even go higher up in the atmosphere, suddenly you can see further, because the vanishing point is then further. So if you take a camera on the beach and you zoom in to the horizon, you can find ships that disappeared below the curvature. So isn't that very interesting that the sun never sets? So does that mean that the Earth is rotating and spinning around like a big potato in space? Or does that mean that the local sun is moving overhead and it's simply moving out of our line of sight?
Okay, here I am. This is my flat earth counter. It continues on into the far distance. I have my camera filming across the surface, slightly above it. This line here is the path of the sun, and I have this bottle here to show you that it's just over 3 fingers above it. As we go down, we have our tropical forest, we have our blue glass cutting board, and some more mountains, if you will, as the sun continues to the end. 3 fingers, we have a level line. I'm going to flip the camera around, stick it here. I'm going to dim the lights and travel to the sun. Let me move my bottles out of the way. Here we go, my sun. See? And here we go. We follow the sun's path, staying level over our flat stationary counter plane. We cruise over the lower mountains. Of course, this is not to scale, and I could do this much higher if my kitchen was just twice as long. And we will get the same effect. I come to the end, to the firmament, and we stop. There's the camera, still at level, slightly above level, standing on the flat earth. So here we go. I'm going along the sun's path, keeping it level to the flat earth. Heading past the mountains. Now, if this is truly the flat earth, I'd have much more distance to go, and I could even have this much higher to get the same effect. We're just finishing, hitting the firmament, basically. And let's take a look.
back on. And I'm going to remove all of the bumps on the earth. To show that I am above the counter, flat earth, I'm going to just slide this along a perfectly smooth flat earth. And I'm guessing that it doesn't set. Because the earth has bumps. To show that I am above the counter, the flat earth, I'm going to just slide this along a perfectly smooth flat earth. And I'm guessing that it doesn't set. Because the earth has bumps. So right here, we have a perspective grid. Okay, this is not a conspiracy theory. It's a grid. Just showing you that the sky goes down and the ground goes up and the viewer is at that middle line. So we have a guy looking down. His eyesight is at that middle line. This is, we can all agree on this, flat earth, globe earth, whatever you want. Okay. And so we have a mountain. Now this mountain is thousands of feet above this viewer as he's looking at the mountain. And we'll watch the sun going away. It's going away. It's not going down. Go watch my Flat Earth Kitchen video if you think that's going down. And it's now beyond the mountain. We know it's not below the horizon. It's beyond where this viewer can see it. Now, if he got up high, higher than the mountain, he would be able to see the sun again. Okay? So does that prove globe earth or flat earth? I don't think it proves either. Okay, because this is just how perspective works. Now, let's move that mountain into the distance, just following the perspective grid. And as it goes all the way into the distance, you can now see a much wider area farther away. So let's fill in that area. So here's that mountain, thousands of feet above his eye level. Fill in the foreground. And it's thousands of feet above his eye level. But it looks like it's at his eye level. The sun will go away, just following that perspective grid, and it's going beyond the mountain. It's beyond the mountain. Now, again, if he went up high, he'd be able to see it again to a point when it's that far away. All right? So now let's fill in the sky. We have the Atmos layer, thanks, Austin, which is clouds or even clear air, but over distance, all of that gets compressed into the horizontal eye zone, okay? It becomes opaque over distance, but we'll look at it with clouds today. And then you have the celestial layer, the sun, above it, okay? So the terrestrial viewer looking through the Atmos to a celestial object above it. As it goes away, it's not going down, it's just going away. It goes beyond. It's going beyond two things right now. All of this clouds and atmosphere becomes opaque again. Okay, so if there weren't mountains there, it would just go behind the clouds, beyond the clouds, which are tens of thousands of feet over the person's head, or maybe 10,000 feet. Who knows? It goes beyond. That's it. Now, the reason that you can't see it again by zooming in is because, one, the mountains are blocking it. Two, the Atmos cloud level is blocking it. And that's it. Now, on a flat Earth, when you're over a flat surface like water, and there's not too many waves, you could lose sight of a ship, but you can open up that layer because you are on the ground layer looking at something in between those layers. But you can't see something that's above the layers because it is cut off from view. There's no denying this. What do you have to say about that?
the sun going down, and the eyes in his head see the world spinning around.
There is a lot of water in our atmosphere. I went to a few websites. I just did a Google how much water is in the atmosphere, and this is the USGS website, usgs.gov, Science for a Changing World. The USGS Water Science School talks about there is always water in the atmosphere. Clouds are, of course, the most visible manifestation of atmospheric water, but even clean air contains water in particles that are too small to be seen. One estimate of the volume of water in the atmosphere at any one time is about 3,100 cubic miles, or 12,900 cubic kilometers. And it goes on to say that if all the water that's in the atmosphere were to rain down at once, it would cover the globe to a depth of about 1 inch. And this is confirmed on a number of websites, but I'll just show you one more just for the sake of argument here. This is the Why Files, the science behind the news. They have an article, How Much Water is in the Atmosphere? It says, at any moment, the atmosphere contains an astounding 37.5 million billion gallons of water in the invisible vapor phase. This is enough water to cover the entire Earth, land and ocean with 1 inch of rain. And of course goes on to talk about that as well. So, yeah, there's a lot of water in the atmosphere. I think we all kind of just know that, but I don't think we've ever really thought about what that means. And so I'm thinking if the atmosphere, especially over water, is made up of zillions and zillions of tiny convex drops of water, then collectively perhaps they all combine to make one big convex lens, in which case it would act like a magnifying glass. Okay, so with that in mind, let's look up some websites dealing with the refraction of light. You might see a graphic, something like this, showing light bending downward. And here's your typical graphic showing how light rays entering some sort of medium, like in this case water, refraction causes the light to bend downward. Now, we've all seen pictures of, a pencil or something in a glass of water, and how not only does refraction bend the image downward, it also magnifies it. I'm going to say that again. Water causes refraction, bending the image downward, and magnifies it. So this is important now. So now back to another clip from that previous video.
The science is the same of that of a lens. Here's a simple example.
So if you're looking at Chicago here, just maybe now you can just see the top of the Sears Tower, and if our simulated temperature inversion moves into place, hopefully now you can see pretty much all of Chicago,
see all the lower buildings,
including what's at ground level.
So the atmosphere really is acting like a lens.
Yes.
The science is the same of that of a lens. Here's a simple example.
The atmosphere really is acting like a lens.
Yes.
Ships do not disappear over the horizon, but rather they disappear into the horizon, with the vanishing point of perspective. The argument of ships going over the curve can be easily debunked by using telescopes, binoculars, and good zoom cameras to bring ships back into view of the observer. No matter how good the zoom is on the camera, ships will never be able to be brought back into view if they went over the curve. This is proof that the ship only appeared to disappear because of vision and perspective, not the curve. Just because the Earth is flat, that does not mean that your eyesight is infinite. The human eye can only see a certain amount of distance on a clear day, and even less on a cloudy day. It would be impossible to see across an entire ocean because the human eye cannot see that far. It has everything to do with perspective and nothing to do with the curvature of the Earth.
Welcome to the empty horizon. Keep in mind that this is an empty horizon. There are no visible boats. As we zoom in, we see two boats appear along what I call the wavefront edge, which is the blue line of last discernible water. We also can see, as we zoom in further, something I call the mirror line. It is a reflection that forms under the boats after they pass the wavefront edge. Two major structural landmarks for this large ship are the top of the mast and also the top of the bridge, which could be considered the top of the body of the boat. It is clearly very large. The mast represents approximately 1/3 of the full height of the boat. Instruments and equipment attached to the mast structure create a visual line that divides the mast approximately in half. This interval therefore represents approximately 1/6 of the overall height over the water. As our target ship passes behind another boat, we can see that it is not going slowly. It is doing something that mariners call making a land against the other boat in a noticeable fashion. We can also note that although the wavefront line is the same, it's consistent for our point of view, the mirror lines are different and unique to each object that is being reflected. The next time that this ship passes against other boats, we have a demonstration of the foreground, midground, and background effect. None of these boats is particularly close to one another in real space, but they look as if they are based on composition. May I also note again that this is not a slow-moving boat. It is traveling at significant speed over water. The background sailboat demonstrates for us an additional factor, the low-lying mist layer that sits over the water and acts as a distorting lens. Both effects are very well illustrated by this next motorboat, seen here entering on the left. The variations in density of the suspended water create visual distortions not unlike that of antique glass. The distortion is most observable in real time rather than when it is paused. The motorboat arriving from the right illustrates for us that it has its own mirror line that is distinct from the one of our main boat in the background. As the large ship continues to move away from us, more and more of it is falling inside the band of mist. Nonetheless, the observable structure proportions remain the same. with the mast representing 1/3 and the body of the boat 2/3 of the space above the mirror line. As the ship proceeded further into the distance, we find this continues to be true even as the distortion line rises to the point where it starts to affect the mast itself about here. The ship continues to move away from us, getting smaller in the distance. The amount of the ship that is inside the distortion continues to rise. As the distortion increases with distance, the white inflatable tender sitting on the deck becomes a white smear and melts into the sea, until only the davit that deploys it remains. The lensing effect essentially acts like a funhouse mirror, stretching the top of the image and compressing the bottom of the image over time. Here, as our ship passes behind a channel marker, we can make several observations. The channel marker has its own mirror line very, very close to our wave front. By contrast, the mirror line for the ship is much higher, seeing as it is much further away. Another indicator is how much smaller the ship has appeared to become. It is now more or less 1 story tall, maybe much less. Watching our ship make land against the channel marker reminds us that it is still traveling at speed and making significant distance over the time of this recording. At this point, both the top of the mast and the spreader bar level are above the height of the channel marker. As the ship moves away at speed, we recall that the interval between the top of the mast and the spreader bar can be used to calculate the expected height of the boat. That height is in no way inconsistent with the mirror line as we see. The distance between the top of the mast and the spreader is about 1/6 the height of the total boat. A small ferry or pleasure craft passes in front of us right along the wavefront edge. And then another much larger ferry passes inside the band of distortion with its own nearer mirror line. As I take this moment to zoom out and observe the overall structure, keep in mind that now the ship appears to be shorter than the channel marker, and yet 1/3 of it appears to be mast, and 2/3 of it appears to be boat. Oh, and I'd almost forgotten. This started out as an empty horizon. Yeah, I mean, like, totally empty. There wasn't anything on it when we started, and that was 18 minutes ago. One last time, to be clear, the distance between the mast top and the spreader bar, and its distance from the mirror line is not inconsistent with the entire boat still being present above the mirror line, but hidden by distortion.
Dreamed of going up to outer space, or maybe meeting other beings from another place? Have you ever wondered what it's like on other planets? Then you watch a science show and come to believe you understand it. You feel empowered by the knowledge and you feel enlightened, listening to Bill Nye and Neil deGrasse Tyson. But then you wake up and you start to see the obvious. Life is just a lie and this whole world ain't what we thought it was. NASA's missions to the moon were never completed. They just filmed them in a room and people believe it. I used to wonder what it's like to be an astronaut. Now when I see them acting, I can't help but to laugh a lot. They give us cartoons and they claim that we live on a ball, but it's flat and it's not moving or spinning at all. Why you lying to us, man? That's something that we want to know. After that, you're gonna have to pack up all your stuff and go. History has been rewritten by winners of wars, the Jesuit order, Khazars, Freemasons, and more. They pulled the veil over our eyes, and it's time to awaken. Through organized indoctrination, our minds have been taken. It's time we take our power back and we rescue our people. The Vatican and the bankers are like Resident Evil. They may have had the greatest plan that was ever concocted, but Illuminati never thought that they'd ever be spotted. They're manufacturing reality all in our heads. They tell us if the earth is flat, then we'll fall off the edge. But if it is a spinning ball, we won't fall off it then. And gravity is our imaginary magic friend. Why is water always flat when unmanipulated? Why are pictures of the earth computer generated? Why you lying to us, man? That's something that we want to know. After that, you're gonna have to pack up all your stuff and go.
It's becoming 100% crystal clear that you and the other space programs that are in operation are connected and are deceiving the entire world. More and more people are waking up every single day. and we are now able to see right through you. But what we really want to know is, why are you lying? Sincerely, me and the great people of this earth.
Space may be the final frontier, but it's made in a Hollywood basement.
The captain thinks the world is round, see? But we all know it's a flat, right?
Of course it's flat. Sure, I know the world is flat.
Well, so do I. Everybody knows that.
So out here, this is Aluja, France. We're looking out over the ocean. Out here is Mount Canigou somewhere. It's 175 miles away. From that elevation, using the Earth curve calculator, not the flat earther calculator, the ball earth calculator, the top of that mountain should be more than a half a mile below the curve. And guess what? You can't see it. On the clearest of, on clear days, you can't see it. Except twice a year, the sun migrates in between the tropics. We can go over that in a minute. Goes from the Tropic of Cancer to the Tropic of Capricorn every 6 months. 6 months out, right in. 6 months out, in. And once a year or twice a year, the sun lines up with the viewer and Mount Canigou. And so you don't see the light that's bouncing off of me right now. You see the light that's bouncing off of me. If I turn the lights out, you wouldn't see me. So the light that's bouncing off of Mount Canigou isn't strong enough to push 175 miles through the thickness of the atmosphere. Somehow the moon does it, but skip that, right? But the brightness of the sun is much brighter. The source of the light is much brighter. And as it moves away, all of a sudden you can start seeing there's Mount Canigou.
So watch here. I mean, we don't see anything here. Now, this on a normal day, people are going to look at this and they're going to come to the conclusion that this is the horizon line. It's a physical separation between where the Earth ends and it curves over, and that's as far as we can see, period. But on this specific day, the sun gets behind and creates a silhouette. So you'll see that coming up here shortly. And the fact of the matter is that these mountains are not floating and levitating in the air. They're just not. They're not a mirage. Doesn't have any of the characteristics of mirage. There's no towering, there's no floating, there's no distortion, there's nothing. That is the mountains of Canigou. Now, when you hear people say, oh, it's just this mountain here, this peak is 9,000 feet, but the rest of the mountain chain is there. So granted, can you see down to 1,000 feet or down to the shore? No, because you're looking over a vast amount of water. And again, reading these things that I read today are just more backup of that, of exactly what's going on here. But here, if you look at, this is not a mirage. You'll see this is not rising, this is not shimmering. This is the mountains of Canigou. And if you put in the curve calculator, here, an eye height of 1,000 feet at that church in Alash and a target distance of 175 miles, you get a hidden feet of 12,380. The mountain peak of Canigou is 9,400. So you're talking about 3,000 feet. These mountains should be, the very tip right here, should be 3,000 feet below the curve. So what do you believe in that's floating these to the top? What is lifting mountains to the top? It's just not what they say. And so, for me, I'm not going to just take their words. Oh, this is okay. It must be an astronomical thing. The sun's lifting thing. The sun doesn't lift mountains up. If these mountains are behind the curve, I wouldn't be able to see them. I cannot see through ocean water, and the sun is not a magic ball that lifts mountains up over water so I can see it. It's just not the way it works. So, and this is not a mirage. That's what they want to try and call it, because there's no other excuse for why we're seeing things at such distances that we shouldn't. And there's still people who go around and tell me that every observation that we see matches perfectly on a globe. That is an observation, and it doesn't match the globe at all. In fact, it would be impossible on any globe unless you believe in floating land and levitating mountain chains.
right there is the top. That top should be more than a half a mile below the Earth curve. Now they'll say, well, this mountain is below the Earth and the sun already set, but it's refracting up. So the mountain, this side of the mountain that doesn't have any light on it, is somehow refracting up and blocking the sun, silhouetting the sun? Or is it that we're just looking across a flat plain and now we can see it because the sun's brightness is lighting it up?
It's starting with the conclusion already in mind and trying to come up with BS to make it work, essentially.
Yeah.
And I've done this test too. If I could really quickly interject here and just pull one up, because this is another test that I did. Was I come from the Pacific Northwest, where there are a lot of great, large, long views with big landmarks everywhere like mountains. And this is one here that I pulled from, I posted this a little while ago, so I don't remember the exact details, but essentially this, I found a bunch of pictures from the Vancouver, BC, Canada subreddit in these online group forums who have taken pictures seeing Mount Rainier in Washington, which is around 200 miles away. And so this is all over the place. People are seeing this, and it's very rare because, like I said, the days are rarely this clear, but it's a really good camera shot of it. And you can use this actual Earth curvature math, like you said, from the globe model itself. This is not controversial. This is how much curve should be happening per mile, 8 inches per mile squared. And
if
when you
somebody,
plug in, go ahead.
Yeah, go ahead. Finish. No, I was going to say about the Earth curve calculator. Someone will Google it, and there is controversy. The controversy is that formula creates a parabola, and we don't live on a parabola. However, it's accurate up to a quarter of the distance around the Earth, which is 6,000 miles. Nobody can see 6,000 miles, so we're only talking hundreds of miles. It is actually, out of the four formulas, it gives the globe the most leeway, right? There's actually more curvature, but it gives the globe the most leeway, and it's the easiest to use. Go ahead.
Yeah, no, thank you for clarifying that, because I now that you mentioned it, I have seen that put out there, but it's not correct, like you said. And using this example, like I talked about, when you plug in the height, and there's more accurate ways, calculators out there where you put in the exact height that you're at taking the picture. Because yes, I know, I think the person took this one from a mountain or something, but essentially the point is still clear that when there's 200 miles of space there, when you just plug it in a calculator, it should be hidden by 2.5 miles below ground level, which it clearly isn't. And all you see here is just flat. And I don't know about you, Dave, but I've gone to a lot of cool places. I love hiking. I go to a lot of great tall mountains you can see super far in the distance. And like you said, all we hear is that, oh, it's just the Earth is just so big that you can't see the curve. Well, no one's ever actually seen it. And at the very beginning of this, you brought up that video of the balloon that was like 25 miles up in the air. Could we pull that up again real quick for people just to really drive that home? Because I think this is just important for people to understand that the only time we've ever seen curve from these high places in space is when NASA or Red Bull is using a fisheye lens. When you watch the full video of that Red Bull jumping video where everyone points to and says, look, you can see the curve right there. When they get down to the Earth and the camera angle flips around, the Earth turns into a donut. It flips the other direction. So it's very clearly.
So here it is, 127,000 feet. The Earth is spinning at 1,000 miles an hour below it to the east, up there for 3.5 hours. So it should land 3,000 miles out in the Pacific Ocean, but it didn't. It went up. And somehow it sped up because the higher up you are, the bigger of a circle you have to make. And it outran the Earth, which is just a little bit of air current, right? And that would never, ever, ever happen on a flat Earth. Here's the Red Bull jump. Here's him getting in, and here's the horizon, and here's him at 128,000 feet. There's the horizon, same camera. There's no fisheye on the internal camera. And, they did 2 Red Bull jumps before this without a fisheye camera that they didn't air. And there's video of that. And everything's flat. Everything's flat. So
also the Chinese space video. Have you seen that one? The
Which one?
China version of NASA, whatever it is, like their Chinese spacewalk. They forgot their fisheye lens, so that one's totally flat too.
So why is it that the Chinese spacewalk is the only spacewalk where they left their fisheye lens back on Earth? I mean, you can watch all of the spacewalks from the Russian agencies, from the European ones, from NASA, and it's a big spinning potato. But then when you watch the Chinese spacewalk, it's a mysteriously flat plane. Now, how could this possibly be? Are the flat earthers on to something? And have you thought about this? Not a single image or video of a rocket ship in outer space is not CGI. That's right. Yeah, we have real footage of rockets shooting up into the atmosphere, but they always follow an arched trajectory and then go back down. And yeah, we have real videos of rockets, kind of high up, but never in space. We don't have any real videos of rockets in space. Apparently we've been to Mars a million times, but we don't have any high-def footage. That's just something to think about. All of these images are different. How is that possible? It's the same planet.
So this is what NASA released, right? Everything's curved, right? And we look at this. So we went in and we zoomed in on all the topography here. This is literally Arizona. I forget what state it was, but it's like one state in the United States, which is a quarter of the Earth. Okay. All right. So and again, people that deny this crap, whenever you see a NASA photo, the curve will be on the top half of the photo, because if the horizon is below the top half, it convexes, because that's how the cameras work. And as you were talking about before, here's a shot going up. Here's the curved Earth. Same camera, same curve. Okay, get over it.
From like the ground.
This is from the ground. It's already curved. Yeah, same curve. It's the same curve. But that's all they got. They got butts and gravity. So there you go. Where we go?
I literally just pulled up the video on like a separate tab and here we go. Okay, what I'm talking about, the donut of occasional effect. Look at this. You can see that it's starting to curve the other way. Like there's one. Look at that.
Yeah, it goes back and forth. It curves both ways.
It's curving the wrong way.
All their rocket launches have the same thing. It goes back and forth, and nobody notices. I think it's revelation of the method. I think they're just literally trying to tell us everything and trying to see who's smart. But think about this. At 6 feet tall, you should only be able to see 3 miles. We can see farther. At 100 feet tall, well, the higher you go, the farther you can see. Okay? At 127,000 feet, you should be able to see the horizon on a globe 618 miles away. Now,
that's about 24 miles for people wondering. Like, yeah.
So, no, 24 miles high. Correct. Right.
Yeah, 24 miles high. Sorry.
So the horizon should be 618 miles away and down below you. Okay. On the ground, if you wanted to see something 618 miles away, it would have to be taller than 250,000 feet. Which is taller than anything on Earth, right? That's how high it would have to be. But you have to add those numbers together. So when you go up into space, right, if they're at that height, the horizon's 618 miles away, that's a 250,000 foot drop, plus you're 127,000 feet up in the sky, so you have to add that up. So the horizon that I showed you was at the same level on that first video, right? Same level. Is the one from up is 381,000 feet below the one that they showed from the ground. 381,000 foot drop, and it doesn't change at all. Again, this is undeniable unless, of course, you can't understand what I just said.
Hey, everyone. If you enjoyed this interview, please help support my work and help wake up others by referring or gifting the app to at least one person today. By doing that, you're going to help wake people up and help me to continue doing other interviews like this. With the censorship out there that's going on, it's very difficult to find relevant information. And the app, as you know, brings people to the truthful information of our world. So help support my work, help support your efforts in waking up friends, family, and strangers. Gift them the app or just recommend the app. And let's make 2025 the year Flat Earth breaks free. Check the links below for information on how to gift the app or just refer the app to others and use your referral code to earn Dome cryptocurrency and a free subscription. Thanks.